Hello everybody, this is again Dr. Sergey Sarkisov, and I wanted to share with us today some tricks that can be derived from the technique of difference of squares. What is difference of squares? Basically, it's when you're multiplying two expressions, two binomial expressions, a plus b times a minus b, okay? And if you expand it, if you FOIL it out, you will get a squared, the square of the first term, minus b squared, which is the square of the second term. Okay, and then why this happens, let's kind of check that, is because, let's say the FOIL method, everybody knows FOIL method, first, outer, inner, last terms, right? Or what I call in my classes, everything by everything, right? Because sometimes you have multiple terms, more than just two, and you can have a middle term, for example. There's no m in FOIL, right? So anyway, what we can see here is, look, a plus b times a minus b, kind of distributing everything out, would be the first terms is a times a, which is a squared. The outer terms are a and negative b, which is minus ab. The inner terms are b and a, right? So plus a ba. And then you have the last terms b and negative b, which is minus b squared. And ultimately, that's going to give us what? That's going to give us a squared plus ab minus ab, those go away, right? Minus a b squared, just like we have mentioned above. Now, okay, that's the difference of squares expression, right? And the question is, what is the trick? What can be done with this that is so fun and fancy? Sometimes people think, well, this is mathematical magic. There's nothing magical about it. Well, let me show you, for example, what can be done. Okay, right, somebody says, hey, Dr. Sarkisov, I want you to multiply 72 times a 68. And I'm like, I wonder what it is. And I tell them 4,896. And you can check me, all right? Tell me what I did. What do you think I did? I did it in my head, yes, but it wasn't anything magical. And that was maybe, for some people, you may consider that kind of quick. Let me show you what happened. And actually, let me do one more example before that. Somebody says, how about a number like 89? I'll tell you, for example, 89 times 91 is equal to 8,099. Okay, wow. Check on the calculator. And actually, I can see the unit digit will be a 9 times 1, 9. And I see this as a 2 times 8 is a 6 units digit, right? So seems like something may be working, all right? What am I doing? Let's see, what am I doing? In fact, if I did another example like 33 times a 27, and you're like, hey, what is he going to do now? I'll tell you, it's 891, for example. All right, and what I'm doing with each of these, let's separate these and kind of do examples. How did I do each of these one by one, right? There's something I did. It wasn't random. I did a little trick. For example, let's look specifically at 72 times 68, right? What did I do for 72 times 68? What do you think? Well, I said to myself, you know what? 72 and 68, okay, they're what? There's a middle term in between them. The average term between those is 70. And that's an easy term, an easier number for me. It's a multiple of 10, right? 70. 70 is easier to work with. So I said, you know what? It's 70 plus 2 times, well, the other one is 70 minus 2. And when you see a plus b, a minus b, you know what? It's the a squared, 70 squared here, minus a b squared, 2 squared. That's what I did in my head. And I'm like, well, I know 7 squared, 49, so 4,900, right? Minus 2 squared is 4. Oh, and then I'm like, oh, 4,896, right? The difficult part for me, the most difficult part, was doing this. And then, hopefully in my head, I would do that correctly to get the final answer, which is that. Same thing, 4,896. Cool, right? All right. What about this one? Well, similarly, this one, 89 times 91, I think it's even easier. What is this? This is 90 minus 1. This a minus b instead of a plus b, and then the a plus b. Same thing, ab is ba. 3 times 5 is 5 times 3 is 15. It's commutative property of multiplication. So anyway, I can do this with a 90 squared minus a 1 squared. And all that is 81 with 2 zeros, 8,100, minus a 1. And what's 1 short of 8,100? It's 8,099. Cool, right? So just be careful subtracting the 1 from the 8,100. All right, there we are. And what about 33 times 27? And we'll play a few more examples and then we'll call it, basically. Just nothing too much more to show here. But look at this. How about this is 30 plus 3 times what? 30 minus 3, right? Is equal to, and then you get 30 squared minus a 3 squared. Oh, that's a 900 minus a 9, and that's 891. Now, are there other ways to do this? You know what? The middle term is the 30 is between them, right? But like, let me show you, for example, what we can do 33 by. Instead of 33 by 27, another number I could have chosen to use, right, would be this one. Let me show you. I could have said, hey, you know what? What if I multiplied 33, and instead of by 27, I could do it like by what? By maybe a 40. Let's see. So 47. So this is different, right? Because look, what happens is, what is this, right? It's a little tougher for me, right? Because what I'm seeing is this like 40 minus 7, 40 plus 7. So 1600 minus a 49, and I'll get 1551, right? And again, that's a little more challenging. Just numbers are slightly more challenging. Let's check, is that correct? Let's see. 40 minus a 7, right? And 40 plus a 7. Okay, that looks, that looks right. And then that's a different way. I mean, it's different numbers completely. But you get 1600 or 1600 minus a, 7 squared is 49, right? And that's equal to, 1551. Cool, right? So these are the results. So you can do other things with 33, not just 27, right? And other ones. So you have to have a middle term, okay? For example, what's another way you could do? Like you could do this. 33 times, let's say 37. Okay, well 33 times 37 may be a little more difficult, but what that is, I'll show you whether I can do that. Let's see. 35 squared is 1,000. Okay, 1,000. So you have to do this a little bit. 900 plus I think it's 1,050. Let's see, 1 second. So 30 squared, 900, plus 5, so plus 300. Oh yeah, 1,250 is what I'm getting. 1,250 minus a, what is it, a 9, so 1,241, all right? And you see, that one's tougher for me. I slowed down there. I should know more, better off. I should be better off with 35 squared being 1,250. And actually not that. It's 1,225, right? And then minus a, what is it, 9? Messed up there. And that's going to be 1,225 minus, what is it, 1,000, so 35 squared. Let me show you what I did there. Wow, this is kind of messy, right? It's 30, I did 30 plus 5 squared. This is a binomial, squaring binomial, and this is what? 30 squared plus a 2, so 10 times 30, and plus a 25, okay? And that's equal to 900 plus a 300, 1,225. Okay, that should be correct. Where am I wrong? Because the units digit's not ending up. It should be a 1, right? Oh, okay, it's plus and minus 2, of course, yes. It's 1221. That should have been correct. Okay, so I was just subtracting the wrong numbers. Anyway, so watch this. You see, you can make a mistake here and there, right? And so nothing mathematical magical about it. But let me show you. What I did here is I said, you know what? It's 35 minus a 2. A little tougher to multiply out 35 times 35, right? 35 times plus a 2, and that's going to be 35 squared, which is exactly the 1225, minus a 2 squared. And see, I made a mistake there, and that's a 1,225 minus a 4. 1,221. That's actually a cool palindrome, right? A numbers palindrome. And you can do other things with these numbers, but you see, it can get kind of messy. So let's just do some kind of random problem. Let's make up some numbers. Maybe let's do 69 times a what? Let's do 71, and I get quickly 4,889. 89. Oops, 99, right? So already messing up, but 70 squared is 4,900 minus a 1, 4,899, right? What if you do bigger numbers? This is actually not so bad. What if I do something like this? Watch this. Let's do like 107, right? Times, and then of course, like maybe let's do 100 plus 7, 100 minus 7, 93. You're like, whoa, what do I do with this? 100 squared is 10,000, right? You have from 2 zeros, you get 4 zeros, so 10 and then 3, 10,000, okay? 10,000 minus that 3 squared, minus 7 squared, which is 49, is going to be 9,951, right? And let's again check these. This would be, let me kind of show you that these are correct, hopefully, right? You can check on the calculator, but we don't, I encourage us to not use a calculator. So this is 70 minus 1, 70 plus 1. I explained how I got this one, right? Which is going to be 70 squared minus a 1 squared, 4,900 or 4,900 minus a 1 equals to 4,899. Okay, that's good. And then the last one, let's make sure we have a better color on that. And we'll stop right after this example. So that was this color here. And so anyway, let's do this with the red solution-wise. And again, you don't have to do this. You can see probably right away. It's 100 plus 7. 100 minus 7. Some people struggle with squaring at 100. It's 10,000, right? And that's because it's going to have 4 zeros, right, instead of 2. And so 100 squared minus the 7 squared equals to 10000. It's 10,000 minus the 49. Oh, that's what's a little bit less than 10,000? 900, right? 9,000, right? 9,900. Oh, and we take away 49, so 51 left. There we go, and we're done. All right, I hope you enjoyed this, and maybe you can do some mathematical magic, in quotation marks, with your buddies, your siblings, your parents, whatever, to show off a little bit. So you tell them, hey, give me a number, and then somebody says, 58, and you're like, hey, I'm going to multiply 58 by 62, and I'm going to get 3,596. What I did was 60 squared minus a 2 squared. All right, cool. Everybody have a wonderful remainder of your day.